Critique the display below, which shows annual per capita carbon dioxide emissions in various countries in light of section 14.7 on how scaling affects volume. So you can see here that they're using a pictograph, and so pictographs are hard to do without being misleading. We know that when we use a pictograph, probably the best way is to stack images and make sure that they're the same size. If we're going to scale the same image and just make it bigger to represent a bigger number, we have to be careful about keeping the size of the object, its area needs to be proportional to the number it represents. And so luckily they've got some good labels here, and they've actually labeled the numbers, because otherwise I would be guessing about where these start. And honestly, really a pictograph is just a type of bar graph where they use pictures instead of bars. I'm looking at this like as kind of like, okay, does my bar end here? Are they saying that this is the bar? Or are they including, like, this is a smokestack, right? So like, are they including the smoke? And so the fact that they've put 18.7 there tells me that they actually are including the smoke, because the top of the smoke reaches 18.7. Here, the top of the smoke reaches 8, and here it reaches about 4.6. So, but I would have been unclear on that. Like, does the bar stop at the top of the cylinder, or does it stop at the top of the smoke? So at least they did provide those numbers to kind of give me that information. But if you look at this, you still have this major issue with the proportionality, right? So like, if you look at China's little smokestack here at 4.6, right? So 4.6 per capita in metric tons, right? So metric tons per capita. If this is the size of 4.6, how many of those could I fit in this picture? Like, I feel like I could fit one here, and I could fit another one here. Maybe not with the smoke, but like, because the smoke's a little wider, but still, like, I could fit like 3 of those, and then maybe even if I account for the smoke, I could fit like 3 more here. And then I could definitely fit way more here. I could fit probably like, I don't know, a couple more there, and I mean, like, I could fit a ton of these, right? And I'm doing a very rough job here, and I'm going to erase this, but like, how many of those Chinas could I fit into the United States? I'm counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of those. But 13 times 4.6, that's way bigger, like, than 18.7. So like, that this is an issue, right? So that in terms of comparing these, it's really hard to compare these based on their size. So, what should I do here? How would I fix this? Really we need same width, right? In bar graphs, we know that our bars are supposed to be the same width. So that's what should be going on here. We need to keep the size of the graphic proportional to the number it represents. And so like, I feel like the heights are good, right? This height is at 4.6, this height is at 8, and this one's at 18.7, but this looks way bigger than it should, right? I'm just going to say here in bar graphs, the bars are supposed to be the same width. So maybe making these the same width, although that's going to give you a really skinny smokestack, right? So maybe making them the same width, or maybe just use bars. At the very least, the pictures, the area of the pictures, or if you decide to use bars, should be proportional to the numbers they represent. And right now their heights are good, but their area, because of their different widths, are not.